Have you ever wondered what secrets lie behind Earth's most breathtaking sights? Have you stared in awe as green and violet lights ripple and dance across the polar night sky? Or watched the sun sink below the horizon, igniting the clouds with wild, impossible shades of orange and deep crimson? Maybe you've seen the ocean itself begin to glow, each wave sparkling with an eerie, magical light. These moments stop us in our tracks, filling us with wonder and leaving us breathless. They seem magical, almost otherworldly, but what if the real magic is the science behind these wonders, written in the language of physics and chemistry? What if knowing the how makes the wow even more incredible? Nature's most spectacular shows aren't just random acts of beauty. They are the dazzling results of precise, elegant physical and chemical processes. So, let's set out together on this adventure of discovery. Why is the sky blue? What creates the fiery breath of a volcano? Have you ever wondered what causes the northern and southern lights to paint the sky with such dazzling colors? These glowing ribbons are among Earth's most breathtaking spectacles. The story of this cosmic dance begins not on our planet, but 93 million miles away at the heart of the sun. Our sun is constantly firing out a stream of charged particles, what we call the solar wind, across the solar system. As this invisible river rushes toward Earth, it slams into our planet's magnetic field, a powerful shield that blocks most of the solar wind. But near the poles, the magnetic field is weaker, funneling some of these energetic particles down into the upper atmosphere. There, they collide with atoms and molecules, sparking a spectacular light show. When these solar particles crash into oxygen and nitrogen high above us, energy is released as shimmering light, green, red, and even violet. Oxygen at lower altitudes glows with a brilliant green, the most common aurora color. Higher up, oxygen can create a rare ghostly red, while nitrogen adds purples and blues to the mix. But the sky's performance doesn't end with nightfall. Twilight brings its own magic. The fiery reds and soft oranges of sunrise and sunset are daily masterpieces painted by the atmosphere. This phenomenon is called Rayleigh scattering, and it's the secret behind the sky's ever-changing palette. When the sun is high overhead, its light travels a short path through the atmosphere. The shorter, bluer wavelengths scatter in all directions, making the sky appear blue to our eyes. Tiny molecules in the air scatter blue light more than any other color, filling the sky with its signature hue. That's why, on a clear day, the sky is a brilliant blue. But at sunrise and sunset, the sun sits low, and its light must journey through much more atmosphere. The blue and green lights scatter away, leaving behind the longer wavelengths, reds and oranges, that set the sky ablaze. What finally reaches our eyes are these warm, glowing colors, a daily reminder of the science at work above us. Dust, smoke, and tiny particles in the air can amplify these effects, making sunsets and sunrises even more dramatic. But what about the wonders hidden in our oceans? The glowing seas and mysterious lights beneath the waves? Why does water sometimes glow in the dark, or transform into delicate frozen lace? What makes this simple liquid so magical? Water is the lifeblood of our planet, and its power to create beauty is nothing short of astonishing. It dazzles us in countless forms, from shimmering droplets to glowing waves. One of water's most enchanting tricks is bioluminescence, the phenomenon of living light that turns the ocean into a glowing wonderland. In the pitch-black depths of the sea or along moonless shores, the water can suddenly burst into a ghostly blue-green glow as if touched by magic. But this isn't magic, it's pure chemistry at work. Countless marine creatures have evolved the ability to shine in the darkness, from microscopic plankton to mysterious deep-sea fish and mesmerizing jellyfish. Their secret? A chemical reaction between a glowing molecule called luciferin and an enzyme named luciferase. When these two meet in the presence of oxygen, they create a flash of cold, living light, nature's own neon show. But water's artistry doesn't stop there. When it freezes, it becomes a sculptor of breathtaking forms. The delicate beauty of a snowflake and the feathery frost on a window pane are born from simple shifts in temperature and humidity, tiny changes that create endless variety. As water vapor cools below freezing, it doesn't just freeze solid. Instead, it forms tiny ice crystals around microscopic specks, each one a perfect hexagon, a six-sided masterpiece shaped by the bonds of water molecules. The way these molecules connect determines every snowflake's unique design. As the crystal tumbles through the clouds, new molecules attach to its corners, growing ever more intricate. Each snowflake is a frozen record of its journey through the sky. Even frost forms through a similar process, as vapor turns straight into ice, painting windows with icy lace. What makes volcanoes erupt with such breathtaking force? What secrets lie beneath the Earth's surface? Deep below, immense and powerful forces are always at work. The Earth's core is a realm of unimaginable heat and pressure, fueling the slow but relentless movement of tectonic plates that shape our world. Where these plates pull apart or collide, molten rock, magma, can surge toward the surface. A volcano is nature's vent, a gateway for this superheated magma, gases, and ash to escape. When the pressure builds, the result is an eruption, fiery, explosive, and spectacular. The explosive power and dazzling beauty of an eruption are the Earth's energy unleashed. When magma bursts onto the surface, it becomes lava, rivers of fire that shape the land. These glowing streams alive with reds and oranges are among nature's most dramatic spectacles. But volcanic heat doesn't just explode. It can also create wonders like geysers and hot springs. Geysers and hot springs are born from the dance between groundwater and geothermal energy. Rain and snow seep deep underground, heating up as they near magma, gathering minerals along the way. In hot springs, this water rises gently to the surface, pooling in vibrant, mineral-rich basins. But in geysers, the process is far more dramatic, requiring a unique underground system of chambers and narrow passages. When water flashes into steam, it erupts skyward in a spectacular display. This cycle of filling, heating, and erupting gives geysers like Old Faithful their famous rhythm, a magnificent water clock powered by the Earth. The Earth's inner fire shapes the land above and below, creating wonders that inspire awe. But what about the world beneath the waves? How does life thrive in the most colorful underwater cities on Earth? What makes coral reefs so vibrant and full of life? Beneath the sunlit waves of the tropics, a world of color and energy bursts into view. The coral reef. Often called the rainforests of the sea, these underwater cities are alive with movement and sound. Everywhere you look, fish dart between corals and brilliant colors shimmer in the clear water. What seem like strange, colorful rocks are actually colonies of thousands of tiny animals, coral polyps. Each polyp is a living creature, building a limestone skeleton and joining with its neighbors to form massive reefs over generations. These simple animals are related to jellyfish and sea anemones, but together they create one of Earth's greatest wonders. Layer by layer, their skeletons build up into vast, living structures that can be seen from space. But what gives coral reefs their dazzling colors and incredible energy? The secret is a powerful partnership, a symbiosis at the heart of the reef. Tiny algae called zooxanthellae live inside each coral polyp, working together in perfect harmony. The coral provides shelter and nutrients, while the algae use sunlight to make food, sharing it with their hosts. This partnership is so effective that up to 90% of the coral's energy comes from its tiny guests. And those same algae are what paint the reefs in greens, browns, yellows, and reds. But a reef is more than just coral and algae. It's a bustling ecosystem. Its three-dimensional maze provides shelter, nurseries, and hunting grounds for countless species. In fact, nearly a quarter of all marine life depends on reefs at some point in their lives. But how are all these wonders connected in the grand tapestry of our planet? How does everything on Earth connect together? When we look at each wonder, is there a hidden thread weaving them all? As we explore these marvels, a bigger, more beautiful picture comes into focus. No phenomenon stands alone. Each is part of a grand living system. Imagine them as threads in a vast, intricate tapestry, the Earth's system, where everything is linked. The sun, the atmosphere, the oceans, the land, and all living things. A volcano's fiery energy doesn't just shape land, it sends gases and ash swirling into the sky, changing the air we breathe. These tiny particles can circle the globe, shifting weather and painting sunsets in brilliant colors far away. Water, too, is a master connector, essential to every process on Earth. Its endless cycle links the oceans, the sky, and the land in a constant, beautiful dance. The sun's warmth lifts water from the sea, fueling our weather and filling the air with invisible vapor. That vapor rises, forms clouds, and is swept across continents by the wind, before falling as rain or snow, feeding rivers that carve deep canyons, or seeping underground to power a geyser's eruption. The same water that falls as rain might freeze into a snowflake's delicate crystal, or become a sparkling droplet that bends sunlight into a rainbow. Everything is connected. Even life itself is woven into this grand design of physics and chemistry. Take the symbiotic algae inside corals, life adapting to use sunlight, water, and minerals in perfect harmony. Sunlight streaming through the water column powers this partnership, fueling the reef's vibrant world. Why is it important to protect the wonders of our planet? What do we risk losing if we don't? The beauty we see in nature is more than a surface-level spectacle. It's the living proof of incredible scientific principles, from the dance of particles in the sky to the immense geological forces churning deep within the Earth, shaping our world in ways both subtle and spectacular. When we understand the science behind these wonders, our appreciation grows deeper, and so does our responsibility to protect them. A rainbow is no longer just a pretty arc of color, it becomes a vivid demonstration of the physics of light, a reminder of the magic woven into our everyday world. A volcano is not just an angry mountain, it is a window into the planet's powerful creative heart, a force that shapes continents and inspires awe. This knowledge transforms us, from passive observers to active stewards of the world around us. With this deeper understanding comes a profound responsibility to act. The same science that reveals the causes of natural beauty also shows us its fragility. We now know that human activities are shifting the delicate balances that create these breathtaking phenomena. Climate change is warming the oceans, leading to widespread coral bleaching and threatening the very existence of those vibrant underwater cities. Pollution dims the stars and creates acid rain that damages forests and lakes. Deforestation disrupts weather patterns and leads to soil erosion, changing the face of the land. We are no longer just witnesses to this grand planetary performance, we are now key actors on the stage. The solution must be rooted in science. By understanding Earth's interconnected systems, we can predict the consequences of our actions and make better choices. Conservation is not just about setting aside beautiful places, it is about protecting the intricate processes that make them beautiful and keep them alive. It's about choosing cleaner energy, reducing pollution, and keeping our air and water pure for generations to come. Together, we can ensure that future generations will stand in awe of glowing oceans, pristine forests, and the endless wonders of our planet. The choice is ours. Let's protect Earth's beauty today and always.